So next up here is floor plans and all of the space sensors in the building. Like we've discussed before, you always have this menu here for each floor. That'll bring you to the floor plan for that floor. So right now we are on the 10th floor. Everything you're looking at here is the space temperature reading from a controller that we have installed. So most of these are coming from the AppStat thermostat, which is KMC, the vendor of all these controls. Their line of communicating thermostats is called an AppStat, APP stat. So that is what's monitoring the space temperature and controlling the local fan coil unit. Each of these buttons is a link to that the graphic for that local unit. So on most of these buttons are linked to the fan coil unit. On the bathrooms that are behind the elevators, we're using the same controller to control a baseboard radiant valve. So all of this controller is the same controller, but all it's controlling is the heating valve in that bathroom, either open or closed based on the heating set point, which we'll go over. Floors 3 through 19 are all pretty much identical. Some of the floors have double units, so this floor doesn't. This floor just has, basically one zone per unit. Oh, here's actually a room that's in fault. So I think we talked about this before. The difference between yellow and orange, and pretty much the same thing. It's just they're a different color, and this one is orange, which is saying it's fault and down. I guess fault takes precedence over down. But if we went here, some of these points are in fault, but they're all down. That's because the controller is down, because either we lost communication or power or something to that controller. But if we go to a different floor that has like a lounge and double units, so some of these units have multiple stats, and there are lounges on some of the floors, but otherwise floors 3 through 19 are pretty much identical. The second floor has some apartment spaces, but then also this common area space. The laundry and 211 are also off of that AppStat, which is the only controller. The only controller on floors 3 through 19 is that communicating thermostat called the AppStat. On the second floor, most of these space temperature values are coming from that AppStat, except for these three here. The air handler 4, which provides fresh air for this area, rooms 212 and 203. Those are ceiling hung fan coil units that operate pretty much identically to the rest, but have just the sequence is a little different. They both have exhaust fans that they control, and actually 212 has 2 fan coil units wired to one controller, so they actually have a slightly different controller with a different thermostat. The same thermostat that air handler 4 has, which is a net sensor. KMC's plug-in thermostat basically just communicates to a controller, a remote controller at the unit, whereas for the other fan coil units and everything, the thermostat itself is the controller that everything is wired to. On the first floor, it's just common area space, the office and kind of kitchen area here. Most of these aren't those AppStats, so we've moved away from those. There's only actually a few zones here that are controlled off that AppStat. Otherwise, there are 3 air handlers, air handler 1, 2, and 3, which have that net sensor thermostat, because they have a more complex sequence and need a different kind of controller, which uses a net sensor as a thermostat. There's also a few different, if you notice these values here, these FC units, these we're communicating with the It's a Mitsubishi split system. So there are a few of these zones on the first floor, and notice they're easily identifiable because we don't get like a decimal value by them. It's just this whole number. So all these whole numbers are coming from Mitsubishi units. They just provide heating and cooling. They're either all in heating or all in cooling. We can talk about that in a little bit, but those provide the heating and cooling for those spaces. In the basement, it's mostly just heating. Besides, the break room has cooling, but otherwise everything in the basement is just heating. Here we're using that AppStat to control unit heaters, and then there's also an AppStat that does the heating and cooling fan coil unit in the break room. We're also monitoring the space temperature for a couple exhaust fans that are wired back to a common controller in this booster pump room. In the penthouse, there's just some monitoring going on. Again, these are over and open just for balance. We're monitoring the space temperature in the mechanical room as well as the elevator machine room. The elevator machine room is just an alarm that, if it gets too cold or too hot in that room, we send out an alarm. The mechanical room has unit heaters for heat in the winter, and which are looking at this active heating set point. So below this heating set point of 65 degrees, we kick on the unit heaters. If we're above the cooling set point of 80 degrees, we bring on EF17 and open the intake damper. So this is the cooling for the unit, for the space, and this is the heating for the space. That's it for the penthouse. Let's go back down to the basement. All of these pick buttons are links to controls for that space, and the value that you're reading is the space temperature from a controller in that space. So usually, if you get a call, hey, we have an issue in such and such room, usually the first thing you want to do is come to the BMS here, go to that floor, go to that unit, say it's 506, go right there, and now you can see exactly what, try and troubleshoot from here what the issue is. So that's kind of how these floor plans. And so like floors 3 through 19, the second floor has some apartment spaces which are controlled by those AppStats. They're all just those fan coil units with heating and cooling. The rest of the space is, and this common area is also that. The rest of the space is a little different. 211 is that the tenant council room is just like the apartment rooms, which is just a fan coil unit with the heating and cooling. There's also a couple spaces here that are a little different. So 203 is a fan coil unit that's hung in the ceiling that also has a fin tube tied to it as well as an exhaust fan. So what we're seeing here is, so it operates the same way as the other fan coil units, except we're maintaining space pressure using this exhaust fan here. So there's an air handler providing fresh air, HU4. So I guess the idea is 203, if we're putting too much fresh air, outside air into the space, we don't want the space to get too positive. So we're monitoring the space pressure here, and if the space pressure increases too high above 0.01 inches, we kick on this exhaust fan to relieve the pressure in the space. Otherwise, this unit operates identically to the other units, except that the stat is a little different because it's a different controller. So it has one of those colorless thermostats, LCD thermostats. It also has a fin tube tied into it, so on a call for heat, it opens the heating valve and the fin tube valve, just because there's that large window section, and I guess just had some perimeter heat across that. Next door is 212, which Shaman has set up as their kind of office right now. This room, because it's larger, has two of these horizontal ceiling hung fan coil units. It's one controller, the same controller as that previous space, so it has the colorless LCD thermostat, but the controller is controlling two fan coil units. Also with perimeter heat tied in, so on a heating call. These two work together, so it's the same outputs, everything, so they both are heating or they're both cooling. The fin tube is tied in with the heating call, so if we are in heating and there is a heating call, that fin tube valve will open. The exhaust fan here we're not monitoring the space pressure in this space. It's just always kind of circulating out air in the space, so I guess we kind of want a negative pressure in this space because the fan is always exhausting and there is an intake damper, so if it gets too negative in the space, naturally we'll pull air through the intake damper as we're exhausting. So the exhaust fan always runs whenever the unit is running, that exhaust fan runs. These fans are set up to actually always run during occupied time, so because these are common area spaces, they're tied into the common area schedule, which we'll talk about later. These fans don't cycle on and off based on temperature, they always run, and so during occupied times the exhaust fan always runs. Otherwise they operate identically to the rest of the fan coil units. We'll talk about the air handlers, the 5 AHUs in a second. I'm just gonna kind of wrap up this other device talk here. Go down to the basement. Some different zones that we have are for unit heaters. So that booster pump room, we're using that colored thermostat, the AppStat, to control a unit heater. All it's really doing is just opening or closing the heating valve for the unit and kicking the fan on and off on a heat call. So, it kind of works like the fan coil units, except it's a single speed fan and it's only heating. So notice we only have heating set points. There's a fusion, so the booth. This room has a unit heater. These two rooms back here are AppStats tied to unit heaters. Entryway for the trash room is a unit heater. And this storage room is just a single zone unit heater with an AppStat. This maintenance room has 3 unit heaters. This doesn't have a conventional thermostat or a adjustable thermostat tied to it. It's just a wall plate sensor at the entrance of this maintenance storage office kind of room. But otherwise it works the same way, where on a heating call we open this valve and kick on the fans, and when we're satisfied we close the valve and turn off the fans. And then there is one heating and cooling unit servicing the fan coil unit, servicing the break room in the basement, which operates identically to